Brought to you by MuleSoft, provider of the industry-leading Anypoint platform for APIs.
Hi guys, I'm Louis. It's really great to be here at APICon, and it's cool to be back in London. I did my PhD here actually in machine learning. Sorry. Yeah, there you go. Got to use the clicker. So yeah, here it is. Yay, PhD. Just a quick show of hands. Who has a PhD here in the house? No one? Okay. Good for you, because actually one of the key messages today is that you're not going to need one to use machine learning and to create predictive applications. So yeah, you can throw it away for now at least. So just to get you excited about building predictive applications, I've included a couple of quotes. So some people talk about it as, you know, the killer app. Predictive is the killer app for big data, or as the next big thing. What else? Yeah, so we're now talking about predictive apps and predictive first development in the same way as we were talking of mobile first development a few years ago. So what do we need to do predictive apps? We need two things. We need machine learning. I'll explain what that is in a moment. And we need data. So it's all cool, we're going to do predictive apps, but there's one big problem, which is that you know, there's a shortage of talent in the area of machine learning. So the industry needs more talent than there is. That's according to the big data report that McKinsey did in 2011. But okay, first things first, what the hell is machine learning? Okay, so that's an email I got in 2013. What's really cool with email programs these days is that they filter out spam, so you get emails and you don't even have to look at it. The program analyzes the email and puts it to spam or to your regular inbox. So it's doing predictive analysis. It's making a prediction. It's answering a question, which is, which type of email is this? And the question and the answer is either spam or ham. So when the answer is one out of a fixed set of possible answers, we call this a classification problem. Each answer corresponds to a class. Let's take another example, which is in real estate. So we see a house and we want to. Sorry.
I noticed that you're not fat. So was that mail? Was it spam or ham?
No, that was. I don't know. You tell me, right? Okay. So that was spam. Okay. So next example, regression. So we see a new house and we want to evaluate how much it's worth. It's coming on the market and we want to say how much the house is worth. So because the answer to that question is going to be a number, we talk of a regression task. So let's talk about classification a bit. Here I've represented data points. So that could be emails, for instance. Let's say that you have two attributes and that you're plotting each data point here. There's two classes. There's the blue one, the orange one. And that's the data that we have, the examples that we have. So we know the labels, we know the classes, we've got example data. And now comes two new objects that we've never seen before, so two new emails, for instance, and we need to classify them. In that case, it looks really straightforward. I mean, come on, the one on the left is blue, the one on the right, it's going to be orange. How do we formalize what we're doing here? Well, actually, we are drawing a line that separates the two classes, and then when we have to make a prediction, we plot the new object on which to make the prediction, and based on which side of the line it falls, we assign a class. So going back to that, that's actually, this line is what we call a model. That's what models or knowledge of how the word works, and that's what we use to make predictions. Now regression. So going back to that real estate example, we have some data about houses that are on the market. So we've got their characteristics, number of bedrooms, bathrooms, and so on. We also have their price. And what we're trying to do with machine learning is to fill in the missing values. So there are new houses on the market. We don't know yet how much they're worth. And yeah, here you go. Everything that's highlighted in light yellow is data, example data that we have. And the rows highlighted in blue are the new houses that you've never seen before. That's the characteristics, and based on these characteristics, you want to predict what the price is going to be. So the blue part is the inputs, the orange is the outputs. And what machine learning does is that it takes example data when you have both inputs and outputs. It goes through a training phase in order to build a model. In the classification example, that was the line. And then it uses, there's another phase which is predicting. So based on the model and a new input, for instance, a new house or a new email, you're going to make a prediction on the output. So you're going to say whether the email is spam or not. You're going to say how much the new house is worth. So you're filling in the missing values in the spreadsheet. So you can think of machine learning, so obviously it's part of artificial intelligence. We're making the computer make intelligent things. But the way that intelligence is built is by referring to examples. And this way it's quite similar to what we do as humans. If we would want to give estimates of house prices, we would look at what's on the market, we would get several examples in our heads, and we would build a model of the dynamics between the relationships between the characteristics of houses, real estate properties, and their prices. So very similar to what we would do as humans. So the big question is, how do I do this bit? How do I build that model? That's where you need to either learn how machine learning algorithms work, or you can use prediction APIs, predictive APIs. So the idea here is to get machine learning into the hands of domain experts, not just people with expertise in machine learning. Actually, there was this. So Brett Victor was a designer on the first iPad, and in a 2006 essay that he wrote, he envisioned that at some point machine learning would be so easy to use that practically anyone could use it, could apply it to data. I'm going to make a simple analogy with website development. So that's my website. That's the web page for the book I wrote. And the traditional way to go about it is to, program it in HTML, CSS, JavaScript. But I didn't. I just used something that's called Squarespace, where you can design websites graphically. You just have to, choose a layout, move things around. It's all graphical, and you don't have to write a single line of code. So tools like that made website development accessible to anyone. And the same thing is happening to machine learning. It's being made accessible through predictive APIs. Right. So we're going to build that model with predictive API, and we won't have to worry about the gory algorithmic details. So there's two phases. All right, train and predict. Train a model, predict with a model. And with predictive APIs, most often you have two methods. One to train model, one to predict. It kind of looks like this. So you take a data set in input in order to create a model. And then with the prediction method, you take the model in input and a new input, so a new house, for instance, in order to get the predicted value. That's actual code using BigML. BigML is one of the prediction APIs out there. And as you can see, it's very concise. There's nothing about algorithms or parameters. what it does is just taking a data set in CSV format. So that would be what I showed you with the houses, but only the lines where you had the price information, okay? So that's the training data. Building from there a data set, then the model, and then using the model on a new input to make a prediction. So very simple to use. And yeah, sorry, I'm not wearing the tie today, but yeah, it's democratizing machine learning. Cool. So there's quite a few things you can do with machine learning, not just classifying emails or you know, predicting the house prices. The first area where you could apply machine learning would be, you know, business. What can you do from that business? I guess the most popular example is churn analysis. In churn analysis, you've got customer data. So you observe what customers do, what their profiles are, and you observe whether they leave your service or not. So the type of business that uses churn prediction is the type of business that charge recurring fees, like, you know, SaaS businesses or anything with that's subscription based. And so you record all that activity of customers leaving your service or staying, and then that gives you training data that you can put into the machine learning system in order to make predictions on who might leave next. And then once you've detected people who are getting less engaged with your offering, you can take action and make them stay, hopefully. Then there's also upsell analysis. So the objective here is to detect people who are likely to be interested in another product that you're selling. Pricing optimization, where you have you're given characteristics of a product and you want to predict what the best pricing would be. Sales optimization, where you have again characteristics of a product and a price tag, and you want to predict how many sales for this price tag. So you can play with the price and see how it changes sales. There's fraud detection, so that's useful for credit card companies, for instance. They want to be able to detect fraud as early as possible, otherwise it costs money, obviously. And credit scoring, so you've got an application for a credit, you want to evaluate the application to decide whether or not to give the credit or not. Okay, applications. So what sort of applications can you build? What sort of predictive apps can you build? The first example that I've got on this list is probably going to be known by many of you. It's the Gmail priority inbox, which is you know, kind of the same thing as the spam classification, except that the two classes are regular email versus important email. So once you've detected important emails, you can put them higher up in the interface. So very convenient for users to quickly get a view of what are the most important emails to read or to reply to. There's Google Now, which if you've tried it, so there's something similar also on the iPhone. There's a similar feature which predicts where you're going next. So you take your iPhone or your Android phone and it tells you, you know, 25 minutes driving time to work. So it can predict where you're going next. Tweet sentiment analysis. So people mention your brand on Twitter and you want to be able to assess whether, you know, it's rather positive or neutral or negative sentiment overall. Crowd prediction, so that's a Paris-based startup which is called Snips. What they do is they make predictions on trains, how busy trains are going to be. So you've got an app that you can fire up to look at when is your next train, and it's going to tell you, okay, it's going to be that busy if you take the 5 o'clock train, but the 5:30 one is going to be less busy. So it does predictions by taking into account a multitude of things related to the context in which you are going to be at that point in time. For instance, the weather forecasts, or if there are any events taking place around where you're going. Then there's, house value estimation. So that's live on a US real estate portal, which is called Zillow. And language detection on Google Translate. Sometimes you just want to translate a bit of text, but you don't even know in which language it is. Well, Google Translate can tell you what the language is and then use that to do the translation. Okay. So there's actually quite a few different predictive APIs. They're not all equivalent. The Big ML one that I showed is one example, but you can come across APIs that are quite different in the way they work. And I'm going to try to explain what the differences might be. So I've listed several types of APIs, going from low level to high level. So the lowest level would be the machine learning algorithm API. So what it is that it's an API that exposes a machine learning algorithm. And if you want to use it, you have to know about the algorithms that are there. You have to know about machine learning and how to tune algorithms, which one to pick in which circumstances. So Big ML is one of them because it exposes decision trees algorithms, and you can actually play with the parameters. Ersatz Labs is quite a famous one for deep learning, but then you're going to ask, what's deep learning? So yeah, if you don't want to spend time worrying about these details, maybe it's not the best type of API to use, but if you've been using machine learning a bit and you want to make it easier to deploy models into production, that might be a good fit. And then there's also the Microsoft Azure machine learning product that's came out recently. And what it does is that it exposes algorithms, machine learning algorithms. Then you've got the automated predictive APIs, which are much easier to use. For instance, the Big ML one, as we saw, don't have to specify anything about algorithms or parameters. Google Prediction API, it does everything automatically. Same thing. So that's a new product, Wolfram Cloud. They added two very high-level machine learning methods in their language, in the Wolfram language, which are, if I remember correctly, classify and predict. So very similar to what we saw with Big ML. These three guys are for classification and regression. But then that's not the only types of problems you have. That's not the only types of machine learning problems you can consider. There's also recommendation. So when you're doing recommendation, the question you want to answer is, okay, given this user, what are the top 5 products to show him? So it's a completely different kind of question. The answer is going to be, a number of products that you specify in advance. And for that kind of task, there are 2 APIs that I recommend you to have a look at, Directed Edge, and then Prediction.io. I wrote offline because it's actually a prediction server that you have to install on your machine so you can make predictions locally, whereas Directed Edge runs on the cloud. And then you have kind of similar APIs where everything is automated, but they are focusing on text classification. So what I mean here is that the inputs of your machine learning problem are going to be bits of text, and the outputs are going to be classes. What about that? Yeah, you'll note that actually you can build these APIs, the APIs that follow, so text classification APIs, and the next one is the vertical prediction APIs. You can build them off of the automated prediction APIs. So they're a bit more specialized. What I mean by vertical prediction API is an API that focuses on one particular problem. For instance, churn prediction. in that case, what happens is that the model that's being created might be more tailored to this particular type of problem, but also the service or the API that you're going to be using is going to take your data, so your own company's data, and it will enrich it with other features. For instance, it might, from the email addresses of your customers, it might gather information from social networks. It's got ways to enrich the data that you have. Same thing for the other ones. Lead scoring, okay, that's a cool one with AI. What they do is that they classify queries, understand the type of queries that you'd make to Siri, for instance, on the iPhone, or to Cortana on Microsoft. So you make a query and it's going to say, okay, it's the type of query it is set a reminder, or book a restaurant. And actually here you can provide your own data about your own queries, and provide your own classes, your own types of queries. And effectively what you can do is build your own Siri for for instance, for a connected object, something that has a very poor interface, and thus you make it so much easier to use. But again, using your own types of queries. Okay, the last one is called fixed model, because the model that you use is always fixed. So there's no training phase, actually. There's no uploading your data to create a model. The model is already there. So the type of things you can do with that is, for instance, sentiment analysis. So saying whether a tweet or a piece of text, a review on the internet, for instance, is positive, negative, or neutral. You've got topic classification, saying whether a news article is going to be about sports or politics or that sort of stuff. There's all sorts of applications. I've come across also readability assessments, or gender detection. So I recommend to check out these things. Maybe it could be all you need, in which case it's super easy to get started. I mean, there's not even data to provide. You just have to ask for predictions. Or you've got something that's going to bring Siri-like features, but again with predefined types of queries. And I've given two very cool computer vision APIs, especially the Alchemy one. So Ensure, if I remember correctly, it's a porn classification API. So you give in an image, and it's going to say whether there's nudity or porn. So it might be really useful if people upload images to your website. And Alchemy, what it does is that it detects objects. For instance, you put in an image, and it's going to tell you whether there's a bike in it, or a car, or a person. And what it does is that it does a classification where it says, yes, if there's a person, no, if there isn't, and it does that for all types of objects. So in the end, you know which objects are in your image. Okay, so now that I've given all these different types of APIs, I want to share with you a list of questions that you should ask when you come across a new API. And actually, I use that list of questions myself because there's more and more APIs coming out these days, and it can be quite tricky to differentiate them. Actually, I wrote a blog post on Programmable Web about that, which is, did I include it? No. Which is 6 questions to ask about predictive APIs. So just for you guys at API Con, here's a 7th question. Okay, so first thing first. Can I sign up instantly? If you want to build a quick proof of concept and just try things, on your own, well, you need to be able to sign up without having to contact sales, or without having the service provider set up a dedicated infrastructure for you. So yeah, I tend to prefer these ones. Then there's pricing. Depending on your budget, I mean, you might want to just try things out, build a proof of concept, and you don't want to make a big monetary commitment. So pricing is going to be an issue. And actually, there's quite a few services. More and more of these services have a free plan. They come with the free plan where you can try out with smaller data sets, and then once you get to use bigger data sets, then you have to pay. But yeah, check the pricing structure and make sure that it makes sense with what your company is trying to do. Then you should look at whether you're going to have to tune any parameters in order to make it work. If you do, then you're going to be spending time worrying about how to get the best performance, fiddling with parameters, with settings, and time being spent doing that is time that you're not spending getting value from predictions or working on the data that you're sending to the APIs, cleaning the data or enriching the data. Then kind of the same thought for cloud, the infrastructure on which it runs. Are you going to have to worry about scaling the machine learning system, or does it just run in the cloud and you don't have to worry about whether it's going to support to handle the load or not? Training data, so that one corresponds to the last type of API we saw. If you don't have to provide any training data, then what you're using is a fixed model predictive API. Otherwise, if you do have to provide data, then it means that you have to spend time working on preparing that data. Type of machine learning problem. So what question are you trying to get answers to? Is it a classification question, or is it regression, or is it recommendation? If you want to do recommendation, then you have to check that the API you're using allows you to do recommendation. You can always use the other APIs to do recommendation, but it's better to find something that suits your needs exactly. So make sure that it's tackling the right type of machine learning problem. Make sure you identify the type of problem you want to tackle, and that the API is a good match. And the final one, so that's the additional one, that's not in the programmable web article. It's the ownership of the model. Who owns the model? Does the API provide the model in white box form, so you can download it and use it wherever you want, on your laptop, on a mobile device, and you can change it and you see what it is? Or do they just tell you what machine learning algorithm was used and with which parameters, in which case you would be able to replicate the results you got to create a similar model, but you're not guaranteed to have the exact same thing. So I'd call that a gray box model. Or is it a black box model? So that's the case with Google Prediction API, for instance. They create a model, but the model stays on their servers, and you don't get to know what it is. So that might be a no-go for certain cases. But on the other hand, if you're just building a proof of concept, or if you just want to see what performance you get, you can try Google Prediction API. It uses the same algorithms as Google uses, supposedly. So you might get extra performance by using it rather than something else. So something to consider. Okay, let's recap. So we've seen two types of machine learning problems, classification and regression. We saw that there's two phases in machine learning. The first phase, you train a model. Second phase, you make predictions with the model. And prediction APIs make it very easy to build models. We've seen a few example use cases in business and apps. In business, there was the churn prediction thing. In apps, there was the priority inbox. And as we saw, there's quite a few different types of APIs. So to help you navigate in that space, remember to ask these 7 questions that we just saw. So yeah, that was the programmable web article. So have a look at that. And all right, so that's a conference that's coming up soon. That's going to be dedicated on predictive APIs. So if you want to dig deeper, that might be something of interest. It's called Papis.io, taking place in Barcelona in November, end of November. And that's about it for me. Oh, there's one more thing. So like I mentioned earlier, I wrote a book which is called Bootstrapping Machine Learning. And if you're interested, if you want to get it, I've come up with a discount code, for you guys. Just use APICon UK, lowercase, and you get 50% off. Otherwise, you can also find lots of free resources on my website, and you can follow me on Twitter. That's it. Thanks for your attention.
Brought to you by MuleSoft, provider of the industry-leading Anypoint platform for APIs.